Alright, LeetCode problem number 3 today. Degree of an array. Lots of downvotes. This will be tricky. Given a non-empty array of non-negative integers nums, the degree of this array is defined as the maximum frequency of any one of its elements. The maximum frequency of any one of its elements. Your task is to find the smallest possible length of a continuous subarray of nums that has the same degree as nums. Num's length will be between 1 and 50,000. Num's I will be an integer between 0 and 49,000. Okay, so what's jumping out at me? It's gonna feel, it feels kind of the same as the last one. Oh. We should copy the method signature over so we don't typo it. Find shortest subarray, nums, int array. Well, we're going to have to touch each element at least once, so we can start out with the for I in 0 until num size. There's going to be no way around getting a for loop. Maximum frequency of any one of its elements. Okay. I gotta be able to quickly recycle whatever is in my brain right now. Hash table's jumping out at me. Smallest possible length. Of subarray of nums. I think we have to do a pass to find the degree of the array first. And then we can do another pass to, okay, so to find the shortest possible subarray of the same degree. Let's do our example 2. This looks like a good one. The output is 6, 6, which is our output. I'm thinking we go ahead and hash. We can find the degree by hashing the number of each element. 1 contains 2, 2 contains 3, 3 contains 1, and 4 contains 1, and we'll be able to do that in n time to determine that the array has a degree of 3. At that point, okay, once we have the hash list, or the hash table, we're going to have to do a for each in hash table and then take the maximum. What if we did a first occurrence and a last occurrence? Because anything outside that bounds would have a degree lower than the degree of the array. Yeah. So we just do a first occurrence. 1. First occurrence. And a last occurrence. One would have a first occurrence of the first occurrence of 2 would be 1. And the last occurrence of 2 would be 2 here, 3, 4, 5, 6. And Length of the subarray, index 1 minus index 6, is 5. 6 minus 1 is 5. 1, 2, 3, 4, 5. Yep. Cool. There's our answer. Okay. So we can do this in... Really, we just have to pass through the array once, and then we have to pass through the hash list once, or the hash map once. So each... Okay, so the trick for this problem is going to be hash map manipulation. Because each element in the array is going to be mapped to a triplet, which contains the number of occurrences, the first occurrence and the last occurrence. And so why don't we do something like this? Data class, what are we going to call this? It's a subarray data. It is a degree. Shortest degree. It has a count, a first occurrence, and a last occurrence. Array data sounds very generic. We're going to call it a degree. It will be instantiated with a variable of I for the index. First occurrence. Variable count equals 1. And variable last occurrence equals first occurrence. Okay, so hashMap equals hashMap of, we'll do a type of integer and degree. For I and 0 until num's size. First of all, let's populate the hash map. Then we can pass through it to find the possible candidates. We can do a variable degree equals 0. Oh, for I and 0 until num size. Okay, so for I and 0 until num size, we're going to do if hash map contains numbers I else hash map put numbers I and then a new degree instantiated with the first occurrence of I. If hashmap contains numbers I, val_deg equals hashmap.get numbers I, hashmap.get 1, degree count, we'll increment deg count, and deg last occurrence equals I. Okay, now we have the data stored in our degree, which is basically a slightly more readable triplet. And then degree equals 0, degree equals 1. If degree count is greater than degree equals degree count. Okay, cool. Now we have our hash map built, and we have our degree built. For E in hashMap. Now I'm not sure if E returns the in hashMap keys. Okay, so key in hashMap keys. Value if E equals hashMap.get key. And I think we can go ahead and assert non-null. Because we did not store any null degrees. And there is guaranteed to be a mapping at that element. So we can assert non-null. Cool. Value E, and then we'll say if E count equals degree, we have to do a variable shortest sub equals lot. One, two, three, four, five, six. 5. That's actually +1. Because of the first and the last occurrence are on the same one. This array has a length of 6. The subarray has a length of 6. If E count is equal to E degree, subarray length equals E last occurrence minus E first occurrence plus 1. If sal is less than shortest sub shortest sub equals Sal. I'll return the case. This setting shortest sub equal to number size is going to take care of the edge case of an empty nums input array. Which we can't have because there's at least one. We'll return our shortest sub. And that looks good. It's only been 26 minutes. That's okay, I guess. Let's go ahead and move this over. I don't think it looks like a good solution to me. It just took me sort of a while to do. Variable first awk, variable count equals 1, last awk equals first awk. Val hashMap equals hashMap of type integer degree. Var degree equals 0. For I in 0 until nums size, if hashMap contain numbers I, tag equals hashMap.get, number is I. Ooh, I forgot. No assertion. Oh, extra parentheses. Else hashMap put nums I degree I if degree equals 0. Degree sub equals some num size for key and hashMap keys. Value equals hashMap.get key. Assert non-null. If count equals degree. Val shortest array length equals last awk minus awk plus 1. If Sal is less than shortest sub. Short sub equals Sal. Return shortest sub. Okay, we forgot the non-null assertion. We're expecting the code to break there. Okay, cool. Type annotation. I assumed it had an inferred type of int without really thinking it through. And here is our missing non-null assertion, of course. Okay. Edge case of 1. Let's run our test cases. Let's try submitting. Oh! Ha ha! Yeah! 100%! 100% faster than Kotlin online submissions. Ah, it feels great. Whew! Yeah. Love that. Alright, I'm just gonna enjoy this for a minute and be like, okay, we're faster than everybody. And we almost got right on our first go. This is a really slick idea. Oh, I'm just gonna be happy about this for a moment. Oh yeah, 100%. Oh, I feel like a boss. Oh man, that's awesome. I'm really happy. Okay, and that's our third LeetCode problem. So we're still on average for 4 a day. I'm gonna end the stream. I'm gonna call this a day on a great note. All right.